Welcome back to C++ session. Today I am starting with more anatomy on functions. Again I am starting with some more questions today. I have one small program for adding two numbers. I have a function, add number function. Now in this line, this control is jumping into this function. After executing this function, how control is coming back to this calling location? After executing this function, the stack frame of this function will get removed. Then how come the control is coming back to this calling location? We can try to find out answer for this question. In our last session, we found some special purpose registers, that is stack pointer, program counter and base pointer. Stack pointer is responsible for memory allocation and deallocation of our local variable. And there are one frame pointer. Frame pointer is a static reference which is throughout constant throughout the program. And there was one more special purpose register, that was program counter. Program counter is holding address of the next instructions. Now we can try to write the assembly equivalent of this program and we can see how this internally working, or how after executing this function, how this control is coming back to this calling location. Okay. Now this assembly will have two portions as we discussed. One portion is address portion, another portion is the instructions. This is address, I am writing address for address, and this is the instruction. Now whenever you need a memory allocation for a local variable, this stack pointer has to decrement with the size of this argument. Now this is an integer, so size of this integer will be 4 bytes. Here assume this address is starting from 1001. Now subtract 4 from stack pointer. Now memory of this I got allocated. Now this 10 has to move into the allocated memory. Assume this instruction is 1002. Move 10 to the stack pointer where it is currently pointing. Now I have one more variable here. So again allocate the memory for this variable, that is at 1003. Subtract size of integer from the stack pointer. So again memory of these variables also got allocated inside a stack memory segment. Now move this 20 to the allocated memory. 1004, move 20 to the stack pointer where it is pointed. Now there is a function call. So at 1005 there is a function called. The name of the function is add numbers. Add numbers. Now there are one more local variable. Again allocate the memory for this local variable. 1006. Subtract size of the variable from the stack pointer. Here size of the variable is 4 from the stack pointer. Now after executing this function, the result will be available in the accumulator. That accumulator value has to be copied into this sum. So at 1007, move accumulator content to the stack pointer where it is pointing. Whenever the control is hitting this close bracket, the stack pointer has to get added along with the size of the local data numbers. Now there are 3 local data number, 1, 2, 3. So here add stack 12 with the stack pointer. This is 1008. This is available inside the text memory segment. This is for the main function. Now I have one more function. I am going to write assembly code for this function also. Again it have two portions. One portion is the address portion, other portion is instructions. Assume this is starting from some other location. Now I have one memory allocation here which is of the type integer. So again we have to subtract 4 from the stack pointer. Subtract 4 from the stack pointer. Now there are two variables that is getting added. So we cannot add directly. You have to keep one in the accumulator. Move this to the accumulator. Then add N2 with the accumulator content. You cannot add directly, so that you move N1 to the accumulator. Then add accumulator value along with the N2. Then you will get the result. Here 2001, move N1 to accumulator. The next one, add the content of accumulator with N2. 2002, add accumulator to N2. So you got the result. Now result is available in the accumulator. Now this one you have to move into the result. That means 2003, move accumulator to result. Now there is a return, so again move the result back to the accumulator. 2004, move result to accumulator. Now control is hitting the close bracket. Whenever control is hitting the close bracket, stack pointer has to get added along with the size of the data, size of the local variable which is available inside this function. So size of the local variable is 4 byte. Again 2005, add 4 with stack pointer. Now we can try to draw the stack frame. This is also available inside the text memory segment. Now processor is started reading, executing line by line. I am calling processor as microprocessor. This is the processor. Processor is started reading, executing these programs line by line. We have one more special purpose register we have discussed in our last class, that is program counter, which is holding the address of the next instruction supposed to perform. I have a program counter also. This program counter is holding this address. Assume our stack is starting from 7000. We can try to draw the stack frame now. This I am drawing stack frame here. Stack frame of the main. Assume address is starting from 7000. Processor is starting reading the instruction line by line. Subtract 4 from stack pointer. Now stack pointer is pointing to 7000. Subtract 4 from stack pointer. This is for allocation for memory I. This is I. Subtract 4 from the stack pointer. This will be pointing to now 6996. Now memory of I got allocated. Now next instruction is move 10 to the allocated memory, or move 10 to the where the stack pointer is currently pointing. So 10 is available here. Now processor is reading the next instruction. Processor is reading this one this time. Stack program counter, processor is reading this instruction. So program counter is reading this instruction line by line. Program counter is one step ahead compared to the processor. Now subtract 4 from the stack pointer. This is for memory allocation for J. Now J 6992. Now stack pointer is pointing to this location. So J also got memory. Then 20 has to move into where the stack pointer is currently pointing. This is move 20 to stack pointer where it is currently pointing. So 20 also available here. Now processor is reached here. Next one, calling the function. After that, this function is getting called. Now the context will be something different. Whenever a function is getting started, base pointer equal to stack pointer. This time base pointer is also equal to 7000. But what happened? Stack pointers keep on changing, but base pointer remains constant. Now, whenever there is a function called, The argument of these functions are pushed into the stack in a reverse order. Now this is I comma j, but these arguments are pushed into the stack in the reverse order. I am going to draw the stack frame of act numbers. Now argument j got pushed. J is equal to 20 got pushed into the reverse order. Now where it is pointing, stack pointer is pointing to 6, 9, 8, 8 now. Again I got pushed into the stack. This one j got pushed into stack. J is equal to 20. After that I got pushed. I which is equal to 10, which is available in 6, 9, 8, 4. Now stack pointer is pointing here. After that, the return address of the function also got pushed into the stack. Where we'll get the return address of the function? Return address of the function which is available with the program counter. Program counter is pointing to the address of the next instruction, right? Then next time, this instruction is supposed to execute after the function call. So program counter have this address. So program counter value or address of or return address. I am calling return address. Return address. What is this actually? That is the program counter value. Program counter is holding the address of the next instruction. So program counter how were supposed to return. This is available at 6980. After that, now the main which is going out of the scope or context of the main is going to some different function. So base pointer will start pointing to base pointer of this function or pointing to the stack frame of this function, so that this base pointer will get loose. So what we supposed to do is we supposed to save the base pointer of the main before moving to the next function. So the base pointer also has to push into the stack pointer. Base pointer of the caller. Base pointer of the caller. Here caller is main. Base pointer of the calling function. Base pointer of the caller has to push into the stack. After that, this base pointer of this function will be the stack pointer 6976. Now 6976 will be the base pointer of this function. Here it will be base pointer of this function will be now base pointer of this function will be this one, that is 6976 will be the base pointer of this function. Now once you have the base pointer of main with you, we have copied. Now you have the base pointer of your current function also. You have the base pointer of the current function as well as you have the base pointer of the caller function. Now it is very easy for you to get whatever the variable present inside the caller function also. You have the base pointer of your current function as well as you have the base pointer of your caller function. Now processor is started reading this instruction. Subtract 4 from the stack pointer where it is currently pointing. So it will get memory for the result 6972. Now it is pointing here. Now the result got memory. After that, what we are doing? We are performing some mathematical operation. What we are doing? Move n1 to the accumulator. What is n1? n1 is 10. 10 we are moving to accumulator. And accumulator content with j. That means these two are both got added. Then what is happening here? Move accumulator content to the result. That means move 30 into the result. Here it is result. Move 30 to the result. Now whenever there is a return result, this result again which is got copied into the accumulator. Again this result is copied into the accumulator. Now this function is getting over. This stack is got removed. What is happening now? You see You have the return address. You know exactly where you supposed to go back. You know the base pointer of your caller, so you know the base pointer of this function. Now you know where you supposed to go back because return address is available here. Where you supposed to go back? This is 1006. This is 1006. You have to go to the 1006 line and you have to execute. What is available here? Subtract 4 from stack pointer. Here what will happen now? Subtract 4 from the stack pointer. This is for sum. Now stack pointer has got removed. Now this will be 6, 9, 8, 8. Now what will happen here? Move the accumulator content to the stack pointer. Accumulator, what is available inside the accumulator? The sum of these two numbers which is available inside the accumulator. This accumulator content has to move into the stack pointer where it is currently pointing. So here 30 is available here. Now once the control is hitting the close bracket, what will happen? The stack pointer has to get added along with the sum of the size of the variable inside this function. What is the sum of the size of the variable? 4 plus 4 plus 4, 12. So stack pointer has to add with 12. So what will happen? The stack pointer again will go back to the old location. This will happen when there is a function call. My question was how this function got to know where it's supposed to go back. How this function got to know whenever there is a function call, this variable has to push into the stack in a reverse order. Along with that, return address also has to move. Who have this return address? Program counter have this return address. So program counter value has to get copied. Then whenever we are moving from one function context to another function, that function's base pointer also has to push. Otherwise we don't know, right, how to refer this variable. So base pointer also got copied. Now he can come back with help of this return address. Hope you understood today's session. If you have any doubts or if you need any clarification, please comment. Thank you for watching this channel. Thank you.